Hi, here we will discuss about classification algorithm in machine learning. The classification definition is which is categorizing a new data which is observing from the environment. The data will be given as a input into the model. That model makes use of that given input data set to learn how to categorize a new observations into different classes or groups. For example, if we are having set of data with labels, my labels are here: apple, orange. Third data point is apple. Fourth data point is banana. Fifth data point is banana. Sixth data point is apple. Seventh data point is orange. So if we are having the 7 data points with labels, then it will be classified as apples will be in one class. How many apples are here? Here we are having the apple 1, apple 2, apple 3. So 3 apples are there, and likewise we are having orange 1, orange 2. So 2 orange fruits are there. Then we are having again bananas, banana 1, banana 2. Okay. So here we are having 3 apples, 2 bananas, and 2 oranges. We can represent by using one is for orange, and here we will use 1. Okay, then we will use 1 here. This is 1. 2 is representing the banana, right? So now it will be classifying into different classes. So we will 0 representing the apple, then 1 representing the orange, then 2 representing the banana. So you look at here we have the classifier is differentiated into 3 classes. So class apple, class orange, class banana. So here we can differentiate this by using different decision boundaries. The decision boundaries will be drawn like this. Okay, so the classifier is an algorithm which is used to map the given input into specific category or specific class. This is the purpose of classification algorithm in machine learning. Now we will see types of classification problems. So what first one is binary classification. This kind of algorithms will categorize the given input into only 2 classes. One class will be classified into yes, another class will be classified into no. Otherwise, one class will be classified into 0, another class will classified into 1. Likewise, if we are having the mail, that mail will be classified into spam or not spam. Only 2 classes will be available in the labeled data. Here cat or dog. Only two classes. There is no other class. This figure indicates our received mail belong to either spam or not spam. Here our model identified or classified the received mail is belonging to the not spam. Second classification type is multi-class classification. In the previous, we have only the classifier classifies the given data into two classes, but here it will classify the given data into more than two classes. More than two classes. Here, look at this. If I have the three pictures, three pictures, in these three pictures, one is dog, second picture is again dog, third picture is cat. So here, if I pass the first picture into our model, then that is classifying into dog. Again second picture is passing into our model, that model again classifying into dog. Third picture is passing into our model, that is classifying into cat. So if fourth picture, if I have the horse, then that will be classifying into horse. So the model will classify the given input data into more than two classes. It is possible to classify the given data into more than two classes. That is the important. So that's why it is called multi-class classification. So different examples are there. The digit recognition, there is 0 to 9, so 10 digits are there. So each digit belongs to different class. 0 is one class, 5 is another class, 1 is another class, 6 is another, like that. Here we are having 10 classes, so multiple classes. Then species recognition, different plants recognition. So the example algorithm here, support vector machine, k nearest neighbor, logistic regression, so many algorithms available to classify the given data into multi-class classification. Third classification type is multi-label classification. Here, you look at this figure, this picture is having objects, multiple objects. In previous, we had only one object, okay? Only one object, that is classifying into particular class. Here multiple objects in the picture, so it is labeling to the this object into cat, it is labeling this object into bird. If we are having any flower here, then it will classify that flower into flower category. Okay, if you are having tree any tree, then it will be classifying into tree. So the algorithm classifies the given input into multiple labels. So that kind of classification algorithm is called multi-label classification. The multi-label versions are specialized versions of the conventional classification algorithm. So here we are having different algorithms: multi-label gradient boosting, multi-label random forest classifier, multi-label decision tree classifier. So with this, the types of classifications are over. Now we will see different components of a ML algorithm. Here, whenever we are using the ML algorithm, that model structure will be represented in the form of any one of the machine learning algorithm. The model structure can be represented in the form of decision tree, or we can use ensembles of models. So ensemble model in here we are having random forest algorithm, boosting algorithms, then instance based models, KNN algorithm, neural networks, or support vector machine, or graphical models, which is having Bayesian algorithm and hidden Markov algorithm, right? So the model can be represented in any one form of these structures, and each machine learning algorithm will be evaluated by using the metrics. The metrics are here. For classification algorithm, we will use accuracy and precision and recall. Then we will calculate the difference between predicted output and actual output. So that will be calculated by using loss function or error function or cost function. So here we will use squared error function or maximum likelihood function, posterior probability, the cost function or margin function or entropy or KL divergence. So different loss functions are there. Depends upon our problem statement, we can go with any one of the loss function to calculate the error between predicted output and actual output. Then after finding the error, we can optimize the model. For optimizing the model, we can go with combinatorial optimization by using the greedy search, or convex optimization by using gradient descent algorithms, or constrained optimization with linear programming. So when we are designing ML model, we have to take any one of the component from models and any one component from metrics and loss function, any one component from optimization methods. So we should consider these components when we are designing the ML algorithm. So ML can be used in different applications: spam filtering, credit card fraud detection, digit recognition, detecting facial recognition, MRI image analysis, recommendation system like movie recommendation, product recommendation, search engines, handwriting recognition, scene classification, object detection and recognition. This is very much important to detect the objects in images, and image segmentation, multimedia event detection, healthcare, web search, finance and trading, marketing, fraud and security, e-commerce, robotics, in education. So many application domains are there. We can apply ML algorithms in all domains. What are the challenges in machine learning? So here we will use the data to train our model. If our data is having poor quality, that means unwanted data, right, with noise, then that is main challenge in machine learning. So we have to identify the noise in data by applying the data cleaning approach. Then underfitting data, the data will not have the bias. So data should, suppose if we are having the two classes, the data we are having 100 data points, it should be balanced. Okay, so at least 45, around 45 to 50 data points to be one class, right, and another rest of the data to be one class. Okay, so here if your data 10 data points to class 1, 90 data points belonging to class 2, so which is not suitable for classification, this is called imbalanced data set. Imbalanced data set, so which will not give you the perfect result but, but in the ML model, so which is underfitting, then overfitting. The testing in training and testing, the model will fit into the training data. So here the machine learning is complex process because we have to choose the perfect algorithm for given problem statement. And if there is lack of training data, if we are having only 10 data instead of 100, okay, then you are lacking with the data, so you cannot train the model by using that 10 data points, and which is slow implementation because if there is any error, again we have to repeat the process. Again if we are getting the error, we have to repeat the process. If we are getting again error, we have to repeat the process. So again and again keep on repeat the process uh, until getting expected result, so which is slow implementation. Imperfections in the algorithm when data grows. So when suppose when we are using the image data or video data, so when we are increasing the number of data, then there is the possibility of reducing the accuracy. So these are all some of the challenges in machine learning. So with this session is over. We have seen classification of algorithm and different types of classifications and the challenges in ML algorithm. Thank you.